another optimization problem. I want to minimize my surface area. So I'm looking for the dimensions that will minimize the surface area, the material I need to use to make this cylinder, given that the volume is 800 cubic inches. This could be made out of cardboard, metal, who knows what, but I want to save money, save resources. I want to minimize the surface area. So, let's begin. How are you, Mr. Haas?
I'm great.
So let's find an equation for the surface area of a cylinder. I think we're getting good at this. Now, we have essentially three surfaces, the bottom, the top, and the wraparound rectangle. The bottom area is pi r squared, the top area is pi r squared, so we have two of those. And the rectangle that makes the cylinder itself is, of course, the circumference of the circle times the height. I think we're pretty comfortable with that at this point. All right, so this looks great, except I have a whole bunch of variables going on here. Can we get rid of at least one of those? Maybe let's get rid of the h because there's only one of them. So let's go back to the given information and see what I haven't used yet. And I know something about the volume. So my volume is 800 cubic inches. Heck, I know the volume of a cylinder. What's the volume of a cylinder, Mr. Haas?
Well, it's just the area of the bottom, the area of the base, which is a circle, very nice, area of a circle, times how tall it is, which I guess you're calling h.
Very nice. This will give me a very handy expression for h that I can then substitute in here. So here I go. I'm just going to divide by pi r squared. So h is equal to 800 divided by pi r squared. And in I go. Boom. So surface area, 2 pi r squared plus 2 pi r times that whole business. Now I have my equation for surface area just in terms of r. Let's clean that up though, shall we? What do you think?
Sounds good.
Throw that over 1. I can do some dividing before I multiply. The pi divided by pi is 1. R divided by one of those r's is 1. So it looks like I have 2 times 800, which is 1600 in the numerator, 1 times r in the denominator. So, as I think you know by now, what I want to do is to find a minimum surface area. I want to find a point where this has a minimum. To do that, I want to find the slope. To find the slope, I take the first derivative. And we know that at a minimum, the first derivative is 0. The slope is 0. So let's take the derivative of this. You know, I think I want to rewrite it before I take the derivative, because I don't want to do the quotient.
Oh yeah, you want to bring that r upstairs.
Yeah, let's
absolutely.
bring that r up into the numerator. Again, I think we're getting good at this now. Move that up, which means I'm going to call it r to the negative 1. So far, so good?
Sounds good. Is that why we do a lot of algebra practice, so they can like move?
I
Yeah,
know.
all right.
I know. It's great. Okay, I'm going to move over here. I'm just going to erase this bit because I think we're probably good. Give myself a little more room. So I've got my surface area, 2 pi r squared plus 1600 r to the negative 1, taking the derivative. Derivative of surface area is just derivative of surface area. I hope that's all right. I'm using 2 variables there. But okay, here we go. 2 times 2 pi is just 4 pi r. Remember, pi is just a number. Negative 1 times 1600. Oh, let's just call that minus 1600 r to the negative 2. That's my slope, my first derivative. I want to find when the slope, or the first derivative, is equal to 0, or where it's undefined. So, at this point, I'm now going to rewrite this with that r squared in the denominator, just because it's easier for me to see what's going on. I'm solving for r. So let's see, I think I'm going to move this over here, add that term to both sides. Wow, this is looking a little complicated, Mr. Haas. Any ideas what I should do?
I think you could multiply both sides by r squared. That sounds good.
Yeah, whenever we have a fraction, you can always get rid of the fraction by just multiplying both sides by that denominator. Goodbye, denominator. Here we have 1600, 4 pi r to the third. Don't be intimidated by that r to the third. We can handle that. Let's get it by itself. Let's divide by 4 pi. This is getting good. And I need more room. Oh, can you see me up here?
Yeah, I gotcha.
Okay, so I have r cubed equals 1600 divided by 4 pi. How do I get that r by itself?
I think you're gonna have to take the cube root.
You're very good at this.
Yeah,
Let's
thanks.
take the cubed root. I'm just going to write that as raised to the 1/3. And that is something that we can, I mean, that's exact form like that, but we could figure out what that is in decimal form by throwing that into your calculator.
And I think I have a student here who's gonna help me calculate this.
Fantastic.
Do you have a calculator
so
with
we
you?
can figure out what r
What's your
is
name?
equal to.
Tyra.
Tyra?
Hi, Tyra.
Tyra is gonna calculate this for us in just a moment.
5.03.
Beautiful. We're rounding it to the nearest 100th place.
Thank you very much. Excellent. Something.
So if I wanted to, I could verify that this in fact is a minimum. You guys know how to do that. Set up your sign analysis, make sure that in fact it is a minimum. So let's skip that for now and let's go ahead and find what h is. I think I erased that, but if you remember, we had that handy equation that h was equal to 800, which was the volume divided by pi r squared. So I can take my radius, and of course you're using your calculator back at home. So you would want to put the full, the full decimal in there rather than the rounded version to make sure you get an exact answer or close to exact as possible. And you're going to end up with
10.06.
10.06 inches. So my dimensions would be 5.03 inches for my radius, and my height is 10.06 inches. And there you have it.